All right, so we're going to talk now about the converse of transversal theorems. So we've been talking about if two parallel lines are cut by a transversal, properties of the angles that are created by those two lines in the transversal. So now we're going to talk about the theorems associated with the pairs of angles. So what these say, some of these are, if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So we knew that if two parallel lines were cut by a transversal, then corresponding angles were congruent. The converse of this is true, that if two lines cut by a transversal and the corresponding angles are congruent, then the lines are parallel. Similarly, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Because we know that if parallel lines are cut by a transversal, then alternate interior angles are congruent. So if the angles are congruent, if the alternate interior angles are congruent, then the lines are parallel. Another one, these same side interior angles are supplementary, then the lines are parallel. Because we know that if the lines are parallel, then same side interior angles are congruent. So in this case, if same side interior angles are, supplementary. If same side interior angles are supplementary, then the lines are parallel. It goes back and forth. The converses of these statements are true. There's two more. The alternate exterior angles. So if alternate exterior angles are congruent, then the lines are parallel, because we know that if the lines are parallel, then alternate exterior angles are congruent. And the last one is that if same side exterior angles are supplementary, then the lines are parallel, because we know that if the lines are parallel, then same side exterior angles are supplementary. So again, this is all converses. The converses of all of these statements are true. And if we know that if a conditional is true and its converse is true, then the biconditional is true. We could write each of these as a biconditional at this point. For this one, two lines cut by a transversal having alternate exterior angles congruent, if and only if, would have to work with the wordage of it to make it sound nice. Lines cut by a transversal have congruent alternate exterior angles if and only if the lines are parallel. Something like that. But again, you want to make it sound nice. You don't just want to say, if two lines are cut by a transversal and alternate exterior angles are congruent if and only if the lines are parallel. That doesn't sound nice. So, you want to make it sound nice. Anyway, let's look at a diagram. Diagrams are great. So I have two lines cut by a transversal. Now, in this instance, I am not told that these two lines are parallel. That's not in the diagram. So I don't know that they're parallel. Now, maybe I am told that this angle equals that angle. Well, if those two angles are congruent, that means that alternate exterior angles are congruent. That means these lines have to be parallel. That means this has to be parallel to that. If alternate exterior angles are congruent, then those lines have to be parallel. That was fun. If I am told that this is angle 1 and that's angle 3, I don't know why, but if the measure of angle 1 plus the measure of angle 3 equals 180, well, since these two angles are supplementary, since same side exterior angles are supplementary, then these two lines have to be parallel. This is what I'm talking about. So instead of knowing that the lines are parallel and finding angle measures, we know angle measures and we're finding whether the lines are parallel. That's really all we're doing. So if you're okay with knowing corresponding same side interior, same side exterior, alternate interior, and alternate exterior, there's 5 different pairs that we're really concerned with. If you know those, then all those properties with transversals, this is really just all that stuff backwards.